by area vector? You know area, right? Since from second standard you have been learning the square, the area of the square, the area of the rectangle. So if I give you square, calculate the area, immediately what you will say, area equal to a square or side square. Rectangle if I ask, L into B. Parallelogram if I ask, base into height. This is what you will tell me, right? But now I am talking about a vector quantity. Okay, by convention, that is in electric field and magnetic field, both the chapters you will use this area vector. Why we are using area vector, I will explain later. But the definition is what? The area vector is a vector. In the name itself, you can say that it is, see that it is a vector quantity. This vector is associated with what? Every area element, okay, of a closed surface, of a surface. Since it is a vector, you know that vector needs how many things, ma? To represent a vector, what you need? You need two things, right? One is magnitude, another one is direction. So magnitude, you can find it as usual using the geometric formula. A square, L, B, base into height, everything, pi r square, circle means pi r square. This will give you magnitude. But how will you give the direction? That is in the definition itself. What is that? Is taken, and the direction is taken along direction. You can take that the direction is perpendicular to the surface. And its direction is perpendicular to the surface in consideration. What does it mean? See, it is given by, I will just give the formula. So usually you write S as the, if you take area as the magnitude as S. Okay, then how to represent area vector? Area vector is given by S vector. So magnitude is S as usual, and here it is in vector. Since we always consider a small element, that's what I am telling you. Here we always consider element when we solve this distributed charge, and that is a continuous charge distribution. So I can use del S into n vector. It is not necessary you should use del S, but it talks about the element. If you just say area vector, you can write this also. This is correct way of representing it. Here del S represents what? Area element of consideration. And n represents what? It is a vector, the direction of the area vector. What is its direction? Its direction is always perpendicular to the given surface, right? So how to find it out? Simple. See, this is one plain sheet. So here you take anything length, parallelogram or rectangle. I have placed it like this on the floor or on the table. I have placed it on sheet of paper. I'm going to consider this is a charge distributed. So how to consider for this plane, how to consider the area vector? The area you will find it out using the formula LB or something, right? Now, how to consider the area vector? Just draw one perpendicular from the surface. How many perpendicular you can draw? Two perpendicular you can draw. One is upward, another one is downward. Two things you can use. Any one thing you can consider it as an area vector. So for open surface, you can draw normal, that is area vector on both the sides. Clear, ma? Is that clear? How to draw? Now consider a circular disc. Okay. Imagine that the circular disc is kept on the table. So if you want, I can just try to draw it. Okay. This way. Now it's okay. Can you imagine it is not facing you? Okay, it is not kept on the y plane. It is kept like this. Now how to draw the area vector? It should be perpendicular to the plane of the circle. This is the plane of the circle. Keep it on pencil. Imagine that you are having a circular plate, and in that you are just placing one fork or spoon perpendicularly. How it will be? The direction is nothing but area vector. So what you will write? Area vector equal to pi r square into n vector. Is that clear or no? Area vector, everyone?
Yes, ma'am.
Area vector is very, very important. So this is what area vector in case of open surface. What will happen if the area vector is in closed surface like cube? If I give you cube has 6 faces, right? And how to draw the area vector for closed surface? Remember that for closed surface, always area vector, direction of area vector is what? Perpendicular to the surface. There is no change in it, but only outward. By convention, we consider only outward. Outward means which direction? This direction, right? Here for the top face, this one. Down face, here. This one. And for this face, it will be this way. Understand? I have done only 4, right? So the back one, it should be pointing this, and the front one should be pointing. No inward flux. Clear or no? Even if you draw, it will cancel out. So for closed surface, how to draw that? Only outward flux, outward area vector, you can draw it. Is that clear or no?
Clear.
Everyone?
Yes, ma'am.
Good. Okay. But in numericals, how do they give it? In numericals, they will say that the given area is nothing but 2i vector. That is 2i meter square. Okay, before we move into that, let us see the graphical way of representing the area vector. So what is this? X, Y, Z, anti-clockwise always. Now, the plane is in which, the sheet, consider this is a conducting sheet or something. This is in which plane? The area is in XY plane, right? Correct? The area in consideration is XY plane. So now I am asking you to find the area vector direction. How will you draw that? It is XY plane. So which one is perpendicular to XY plane now? The Z axis will be perpendicular. You know that X, Y, Z in Cartesian, all three are mutually perpendicular to each other. So it should be perpendicular to XY. So you can take it in positive Z direction or negative Z direction. So what will you write area vector direction? Either K vector unit vector or minus K unit vector. Since it is a square, if I take it, then what you will write? The area vector is given by, for this diagram is S or A, whatever you are convenient, you can use it. It is nothing but A square. And what is the direction of the area vector? You can take it as K or A square minus K. For open surface, both are allowed. Is that clear? Everyone? If it is
Yes,
not, now this is X, Y, Z plane. Now find out what is the area. Okay, that's the area in consideration. Which plane it is, ma? Which plane? It lies along the YZ direction, right? So what is the area vector direction? Tell me, any one of you. YZ plane is x-axis, either positive x-axis or negative x-axis. Both are okay. So you can take minus I cap or plus I cap. Plus I cap means what? You are representing positive x-axis. Minus means you are representing negative x-axis. Is that clear? So one more thing, write out. In x, you know this, it will be very easy to find out the electrical flux associated with the particular given surface. So, shall I move to the electrical flux?